just going to call her. Hey everyone, please come to the front stage. We are going to start the event. So please, everybody in the back, come to the front. Thank you very much. I'm going to go in the back. And I introduce you as the MC. That's what then you go on.
Okay.
Does that work?
Yeah. Should we switch to this side then?
Yeah. Is everyone in the front? Or please, everyone, if there are still people in the back, please come to the front. It's about to start. Thank you very much. I'm gonna do the last. Okay, thank you very much, everyone. Welcome. So I am Cedric Vidal. I am the organizer of the event. And tonight, Pamela Fox is going to be the master of ceremony. So I will let Pamela start the event. Thank you, Pamela.
All right. Welcome to the AI Show and Tell event here at the GitHub headquarters. How many people have been here before? All right. How many people haven't been here before? Okay, so I just make sure everything counts up. All right, well, this is an awesome venue. It's super fun. It's also where we have the SF Python, if any of you are Python developers. Anyone does Python here? I got a few. All right. Sweet. So this is a great venue, and it's super exciting to be here. Cedric and I are both from Microsoft. We work in developer relations, in advocacy. He works on AI. I work on Python, which is basically the same thing now. So we get to work together a lot. It's great to see so many people here, and we're excited for the talks that we're going to have today from our three fantastic speakers. So what we're going to do is have these three speakers. They're each going to give 15-minute talks, short and sweet. And then afterwards, we'll bring everybody up to do 25 minutes of a panel and Q&A. So if you do think of, great questions while you're watching the speakers, try to hold them in your brain or cache them in your database or whatever, and just remember them until the panel and Q&A, and hopefully we'll have time to get to several of your questions and hear from all the panelists and have all their insights shared. So that is the plan for tonight. We are going to actually start off with Michael doing our first talk from Tambo, and then we will have SallyAnn after that, and then Philip after that. So let's bring up Michael to connect his machine. All right. You want to use that mic?
Yeah, that works. All right. Hi, everybody. My name is Michael. I'm the co-founder of Tambo AI, and we're building a React package for adding interactive UI components into your AI assistant. And I'm actually going to spend the first half of my talk talking about this new concept that I'm excited about, which is intent-driven interfaces. So I'll tell you a little bit what that means. But to get started, every software interaction starts with intent, right? No matter how the UI looks, a user has an intent, then they use their eyes to navigate around some site to get to the solution to solve the intent that they started with. But I think we're in this new era where somebody can basically have an intent and then input that intent directly into their computer or device, whatever they're using, and then have the UI basically come to them as they need it to solve the problem they're trying to solve. And this is like a much better overall experience for users, but we were limited by the technology of the time to use UI as the path to get users from an intent to a solution to their problem. So intent-driven interfaces is a broad spectrum. There's a lot of different types of ways people are doing this today. There's the Canvas UX, for example, chat UX, people talk about that, or what I like to call cursor UX, which is the new shorthand for this, which is, hey, I'm building a cursor for, and then fill in the blank software. And there's some pretty great opportunities, I think, in this new paradigm. So one of the biggest problems that I think it solves is feature discovery. And this is one of the hardest problems in UX right now, to show the right feature to the right user at the right time. And what we can do is start breaking down UIs into their primitives and then allowing the LLM to render them as the user needs them based on intent. Another interesting opportunity with this type of new paradigm is what I call personalization. So personalization used to be limited to companies at hyperscale where they had lots of data, lots of users, and could build algorithms to personalize somebody's experience. But context is basically personalization today, and I'll give you some examples. So let's say I'm using an app and I tell it to send an email, for example. And it generates some email that's overly formal, for example. I could tell it, hey, make this email more Gen Z, and then it will return an email that's structured in a less formal tone. Now, the next time I send an email, it can have a memory or use context from my previous interactions to say, hey, this user prefers emails written in Gen Z, and then it returns that the first time without me having to ask. And that's basically like personalization at any software level. Another example is like what I like to call like personalized workflows. So instead, let's say a similar example where the user wants to send an email. It remembers that I like to write in Gen Z, and then afterwards I tell it, hey, could you add an opportunity to my CRM? And then it shows me some sort of UI with opportunity, like an opportunity filled in for me. Now, what it could do is next time I send an email, it shows me this UI, and then it says, hey, suggest, why don't you add an opportunity? That's what you did the last time. I just select yes, and then it does the same interaction. And so that's a workflow. It's already a huge improvement over most workflows in products. So a lot of workflows in products, you have these really complicated workflowing softwares. You have to build out this workflow in some sort of canvas. And instead, basically, this is all accomplished just with context. But you could do even one better, where you just skip the asking the user for confirmation, and once they've done it enough times, you just show them the next UI element inline. So this is what I call like accidental workflows, where the user creates these workflows just by using the product, and the product just gets better with more interactions. Another interesting opportunity with this new paradigm is feedback. So every software product is built this way today, where you create some features, hopefully you talk to some users first, have some ideas of what the problems are, and you add this feature, you have users try it, and then they have some issues with that feature, they don't know where to find it, they don't know how to use it, and then you gather that feedback, and I'll talk a little bit more about that in a follow-up slide, and you improve the product. And this is how we built products for the last 20 years. And it's often called the build, measure, learn cycle. So how are some of the ways that we measure or gather that feedback in products today? So we could conduct user interviews, so we just talk to users, we watch them use the product, we see how they use it, we see what problems they run into. We could try and do this at scale with something like user testing, where we have a bunch of people on the internet try it and give you feedback as they're doing it. We could start recording their sessions and watch people as they use the app live or in reality. We might add, if we're at a certain scale, we might have analytics. We might do A/B testing to try and understand how a feature is affecting certain users. And we might even do these really annoying surveys that just pop up randomly in your application. This is my least favorite by far. I actually got one last night when I was making this presentation, and so I thought it was pretty funny. But yeah, so we gather all this feedback, and in this new paradigm, people just give you that feedback. They literally tell you what they don't like about it, what they want it to do, where it worked and where it didn't work. And so there's this really cool opportunity to collect all that information as people use your products and feed it directly into the product team of what they're looking for without having to use all of these kind of opaque ways of actually doing it. So in summary, this new paradigm, I think, improves feature discovery, helping users find the functionality they need within the app. It allows for personalization in a way that wasn't possible before. And it's also a much better mechanism for collecting feedback from your user. So I'm going to give a quick demo. So this is the Tambo AI dashboard. And we actually took all of the components in the dashboard and registered it in a chat. And so I can just start accessing that different functionality that we built into the app through messages. So in this case, I'm asking it to show messages in one of our showcase projects. So this found the project, found the UI component it needed to show the messages, and this looks exactly like how it does in the other part of our app. And then the user can interact with it just like they would any other type of UI. So now that I'm done looking at this message, maybe I'm curious, hey, how many messages has the showcase sent per day? And we also have this graph component that's in another part of the UI, and I can just instantly access it in one flow. And then one thing I also really like about this kind of pattern is that in our app, this is actually called instructions, but I put in prompt, and the AI was pretty good at figuring out that prompt and instructions were the same thing. And so I can just go ahead and update the instruction. I don't have to find where this lives in the app. And so actually close this, and then you can kind of see me quickly navigate to that the old-fashioned way and see that basically this went ahead and updated, and that's the exact same UI component you saw before. All right, so what are some of the challenges, and how have we solved that at Tambo? So one of the problems is registration. So how do you keep the server and client synchronized between what components exist on the front end that the AI assistant can use when it's displaying information to the user or asking for interaction? And then also, how can you make sure the LLM is in compliance with the prompts and passes the right information to the component that it expects? So we've built our React package in a way where you can use something like Zod to define properties, or sorry, a type for your component. So in this case, it's a subject and a message. and then you can infer that type and use that how you would typically, and this is TypeScript, for a component. This is a very simple form component for displaying the email subject and an email message. And then you would register that component in we call it a registry. It looks very similar to registering OpenAI tool calls if you've done that before. You have a name, a description, the component to be rendered, and then the schema that that component expects. And then we have a Tambo provider where you pass that registry in, and then it gives you a bunch of hooks for managing the state of the chat and then rendering the component based on the AI response to the user's message. So another challenge is in rendering it. So you have to hydrate the components with the props, and then you have to deal with the latency and streaming of rendering that component. And so we actually handle all that for you inside of Tambo. So Tambo will basically get the response, render the component, start streaming in the values, and then we also have some more hooks that we provide to let you control how the component handles partial states as the message streams into the component. And then another big challenge you run into is state management. So when the user can then interact with the components, how do you pass that interaction state back to the AI, and then managing the state of that chat as users kind of like can go back and forth between chat messages. And so one of the ways that we've solved that is we provide a state hook. It's very similar to useState, and you basically by using it, you use it just like you would use a state hook, and then it passes that state up into the AI chat automatically for you. Another big challenge is observability. So now that your website is broken down into these primitives, all of those components can show up in different places, and you're going to need some way for trying to parse out what's happening in the UI. And so we started building this into Tambo. You can look through a message thread, see all of the tool responses that it received before it rendered a component, and then you can also click around to find the component rendered, see what props were passed to that component, so you can help understand like what happened in case there's some issue or didn't render the way somebody expected. And then something that we're working on is this concept of UX insights. So now that you have all these users having these chat interactions, they're basically generating feedback about what your product should do or what errors it's running into. Like, hey, maybe somebody's trying to do something and you're getting errors. It can track that for you, but it also could start surfacing, feature requests, things people are asking for, edge cases people are running into, and that's something that we're really excited about building on top of this platform. So in summary, what we've handled is kind of the registration of all the different components in your UI, how to render them as the AI chooses to render them, how to pass the state back from the user interaction to the AI, and then how do you observe what's happening in the entire system. And then what we're working towards is providing the UX insights of how do you improve this product as you go forward. And actually this weekend, we're running a hackathon. It's global. We already have 100 signups, launched it like a week and a half ago, so pretty early. But if you're curious on how to use Tambo, I'm going to be spending a bunch of time over the weekend helping people use the product, so great opportunity to try it. There's also some other really cool sponsors like Lingo and Autumn. And then this is our website, so if you're curious about just using Tambo some other time, you can see our website. We have a demo on the web page, and then we have a bunch of docs about how to get started. So that's it for my talk, and I have 3 extra minutes, so I'll answer questions later, I assume.
Yeah, I think we're going to stick with that, but yeah, save your question for later. Thank you, Michael.
Thanks, everybody.
That was awesome. Yeah, I'm actually a full stack developer, so I always get excited when we actually hear people talk about, the user experience, because a lot of these applications that we're developing do have a user-facing experience, and it's really important that we make it great. So next up, here we go. We'll have our next speaker, SallyAnn from Arise. We'll just get her connected. And Arise is a fun platform I've used before. So
Awesome, love to hear that. Hey everyone. I'm SallyAnn. I'm one of the product managers at Arise. I'm going to spend a little bit of time today talking about agent evaluation and agent workflows. Before I can do that, I must introduce us first. So we're Arise. We do three things really, really well at Arise. We help with development, so workflows to develop, experiment, and test changes for your LM applications. Evaluate, which we're going to spend a decent amount of time talking about today, where we can perform in-depth analysis of experiments. And then observe. So we're going to function on top of tracing. So we're built on top of OTel. So all of your LLM application data can go into our platform. And then we have all of these workflows built into Arise. Now, I want to give a little bit of context. I'm going to spend very little time in slides. We're going to mostly be in the product. I was feeling a little brave today, so I'm going to do a live demo for the rest of this. But I'm going to give a scenario of what happens when an agent goes off script. So say we have a trip planner who receives a user request that says, book me the cheapest flight from Denver to SFO. This is something I do all the time. I live in Denver. And the router misclassifies the intent as hotel booking and triggers this hotel search tool instead of the flight search tool. And then the agent replies with these irrelevant hotel options for San Francisco. And now the user's super confused and nobody's using your product. This is like the worst case scenario for a PM, right? And so this is like what can go wrong. And so this is really why agent evaluation matters, right? Agents are super complex and they're only getting more and more complex. It's the year of agents. We're seeing multi-agent frameworks becoming more popular. And so because there's these chains of decisions happening, one single step that is wrong can be, this zero-shot metric spike. And so the traditional output metrics of things like error rates or latency, they're just not going to be enough to really understand where these like half-done tasks are happening or when there's wrong reasoning, things like that. And so evaluation is the only way to really create the structured feedback. So I just want to set a scene a little bit about why I really feel like evaluation matters. I'm going to skip some of these and then give this systems approach because I'm going to go into a little bit detail of this as we go through. So you really can't just evaluate your outputs. You really must break down the agent's behavior into these really discrete steps. Ask at each point, what is the right decision? And then think of it as kind of like a debugging problem. So inputs, reasoning path, outputs, we need to really evaluate at each step. So we can jump into the platform here and start going into it. So this is the Arise platform. Before I kind of go through the traces, I actually want to demo something before we look at the underlying data, which is our agent that we've built into the platform, Alex. So anywhere you see kind of these sparkles in the platform, that means we've built our AI agent into it. Alex is supposed to be your helpful assistant for Arise. So it can do things like search over data, but as I show you, it can also debug your traces. So this is relatively new. Copilot was its old name, and now it's Alex as we're going full agent mode here. So I'm going to go ahead and ask Alex just to summarize this trace for me. And while that's doing that, I'll describe a little bit about what data we're looking at here. So in case anybody's not familiar, this is an LLM trace. Basically, a trace is going to be a collection of spans, and spans are individual units of work that your LLM application is taking. So this is a super basic RAG application, and I've just asked Alex to go ahead and summarize what's happening. So taking a look at this, it did some reasoning. It's basically saying that it's using an LLM model. There's maybe some questions around the UMAP here, and basically it says that the model is incorrect due to hallucination. That's not a lot of information, so because this is RAG, I'm kind of interested in the retrieval, so let me go ahead and add in a specific span here. So something that we've just added to Alex, this might look a little bit familiar from your favorite IDs, is the ability to add context. We've been doing Alex for quite a long time, and we've really realized that context is going to be super important for our users' experience. We've experienced it in using our favorite coding IDs, that it's a lot simpler to get a good response when you can specifically tell the LLM what to do. So I'm going to say debug my retrieval. Ooh, what did I do? Live demo, see, I told you I was feeling brave. No worries, we can get back to it because I have we'll just start with the new one. No worries. Okay, we'll just say here, debug this retrieval. And so now not only do I have the trace ID, but I have the specific span, so Alex is going to take a look at that and then go ahead and do a little bit more of analysis. It's saying that it really didn't successfully fetch the right documents relevant to the user's question. So pretty straightforward. Last thing I want to show off here is you can also go ahead and add any context. So these are evaluations. I'm going to get to these in just a second, but say I want to go ahead and send Alex all of the explanation for my eval, I can go ahead and do this. So I won't wait for the reasoning because I want to make sure we get to the other good parts of the demo, but I wanted to show everybody this because we're actually going to go look at a little bit of Alex's underlying data, and I wanted you to see kind of how we interact with Alex and how it works. So I'm going to jump over here to a different project I have. This is real Alex data. It's just scrubbed so that none of my customers' information is in there for you all to see. And so we can actually take a look under the hood. I don't have any data for that specific trace that we're looking at, but we can take a look at one of our other popular skills, which is AI search. So you can imagine when you're looking through data, there's some things that are structured. Maybe you want to look for a specific model provider that you used or some metadata tag, but what happens when you want to find something like frustrated users? You can't really create a structured query for that. So that is why we went ahead and created AI search, and this is the underlying data that powers AI search. So what I want to start calling out here is if you look at my data, you'll see that there's evals at a lot of different levels. And that kind of calls back to those earlier slides that I was showing you where we really believe when it comes to agent evaluation, it's really important for you to be able to evaluate at each decision point. If we just evaluate at the top level and you got QA incorrect, what does that mean to you? You don't have any idea. So being able to go ahead and look at each individual unit of work and evaluate it is super important and something that we're really passionate about. So I'm going to start here at the router level. For anybody who's not familiar with what a router does in an LM application, usually this is going to take an input and it's going to have a set of tools or functions available to it to complete its task, and it's going to pick the best one. So, ooh, I picked a bad example where this one only has one tool. Let's go up here. There we go. Okay, so say we had these 4 functions available. You can see that it went ahead and it chose the text to filter. Let's go take a look at our evaluation. So at the router level, I like to evaluate 2 things primarily. One, I want to know, did my router choose the right function? That's pretty basic. Something that's super important, though, to make sure that it chooses the right function. But then when it does decide that it has chosen the right function, I also then like to evaluate whether or not the arguments are correct. Because what can happen is you can call the right function, but call it with the wrong arguments, and then that can totally change the trajectory. So that goes back to all those little individual decisions that are being made and how they can kind of compile to an incorrect result. The next thing that I care about is the task correctness. So I've maybe picked the right function. Did it actually execute that function correctly? So now I have something called the task correctness eval, where I can go ahead and understand, okay, was the task correct? And then what I like to do is actually bubble this all the way up to the top. This is a very simple trace, but you can imagine as things get more and more complex, I have more and more spans, there's going to be a lot more decisions points, and I still want to know at a top level were things correct or incorrect so I know where to go look. And so that's what we're doing here with this QA correctness eval. The way that I like to do this is actually take all of the evaluation data in the underlying spans and put it in as part of the prompt. So it's injected as prompt variables into this evaluation template. The reason is I talked about the explanations when I was doing that example with Alex. These explanations are really, really valuable. This is kind of the reasoning behind why your LM as a judge actually provided that label, and I think it's actually more valuable than just the label itself because it gives you kind of insight into exactly what went wrong. So if I went ahead and I picked an example here, let's say that had that top level incorrect, what you can start to see here is exactly where things went wrong. So we can see in this explanation, the task was not executed correctly. Given the examples were addressing things about SDK, it called the wrong function. And so now I can kind of understand exactly where things go wrong. This is super powerful, right? Looking through all of our individual traces, but when you're at scale, you're starting to get, thousands, millions, tens of millions traces are coming in. You can't possibly start looking at every explanation. And we have tools that Alex can do to summarize, but I want to show off another thing that we've built just to visualize and work for your agents. So we just released this last week. This is our graph visualizer. It comes out of the box for any of your primary like multi-agent frameworks, things like LangGraph, Crew AI, AutoGen, all of those, but you can also do it for anything custom. So what this graph is really meant to do is abstract a little bit of a higher level than your traces so that you can understand the general high-level concepts and the paths that your agent is taking. So rather than needing to dig through all those traces, I can start to understand exactly what the different paths are. It's a little hard to see, so I'll zoom in. You get this nice animation. And these are all kind of consistent because I have consistent data here, but imagine you have one path that's like way more popular than your other paths. You'd actually see those as visual components here with, you know, larger nodes, thicker edges, and you can start to understand exactly what those most common paths are so that you can know that maybe I should look at that data a little bit closer. You can also see things like any self-looping happening. Say you have an information gathering step that happens first, but your agent is getting stuck there and it's never progressing to the other pieces. You would be able to see that here rather than looking at your traces right away. And so that's the idea, is like we have to be able to debug these agents at scale. Clicking through traces is not going to be the solution. So we're borrowing kind of from common data visualization practices here and giving you a way to first get a visual check. And then of course you can kind of start taking a look at your data. We overlay some of our eval information there. So this is like that search. You can start to see exactly how things are working. So here at the router level, we're seeing argument correctness. But if I took it up one level and looked at the planner, I would actually be able to see that, okay, for my LLM questions, my general chat, I'm doing pretty well. 84% of the time it's correct. But for search, I'm about 50-50. So that's probably where I want to invest my time in investigating. So I can go ahead and inspect the path, look at the underlying spans associated with it, and then if you want to do something like, you know, start diving into your traces, one click, now you have all your traces, and we can start layering on top of that. So perhaps then we're like, okay, let's add in a layer for those incorrect. And now I have just the data that I need. So rather than looking at a million traces and trying to find the needle in the haystack, I can kind of start at the node visualization, work my way in, and then, you know, add filters on top of that till I have just the data that I need. Perhaps from there, you can go ahead, add it to a data set, take it to our prompt playground, run an experiment on it. This is where the workflows really kick off. But the agent visualization here really helps. I'm going to show one thing because I have a few more minutes left. There's another feature that we're going to be releasing early next week to go along with this, because this is really great for super complex and understanding how general concepts are interacting with each other. But we'll also be, oh no, releasing, give me 1 second. Live demos. Okay, I guess I'm not going to be able to show you. Okay, wait, I have something I can show instead. I have a video recording of it, guys. Let's see. All right, let's see. Will this work for me? So this is going to be, yes, a single agent visualization that we're also going to be releasing next week. So the node is really great for when you have these kind of high-level concepts, but when you want to kind of just understand your linear flows or a single agent, this visualization works just the same, but I think of it as like a in between your traces in the graph. The graph is going to be super high-level. You control the concepts. This is going to be based off of your trace data, but still it's like an aggregated trace. That's the best way to think about it. But yeah. That's it from me. Thank you all so much. I'll be around for questions, and I have socks if you'd like some swag.
All right, thank you, SallyAnn. That was great. I hope everybody is evaluating your applications, just like everybody has full 100% test coverage for all your apps. It's actually really, really helpful to evaluate, and you'll learn so much about your apps when you do it using tools like Arise. So next up, we have Philip. Let's plug you in here. Philip is coming from Base 10. Has anybody seen the Base 10 billboards at the BART? Or the buses, right?
We got buses.
Yeah.
Ooh, that's a good mic.
I've seen those billboards all over. I guess they're at my favorite BART station. All right, welcome, Philip.
Can I grab that guy?
There you go.
Thank you. I'm a big walker. I like to walk around, which means you're going to see me doing wind sprints over here to go next slide. Thank you all for being out here tonight. It's an amazing crowd. Love to see it. I'm going to talk about 5 things you need to know about AI infrastructure as you scale. Why am I going to talk about 5 things? Because I started as a content writer and never really grew out of listicles. But I promise it's going to be fun. So I'm Philip. I work on AI infrastructure with a bunch of these awesome folks at Base 10. Actually, this photo's like a year old, so there's like 3 times as many awesome folks. And we are working on, scaling AI infrastructure for some of the largest and fastest growing AI native startups in the world. So I'm going to talk about the challenges of building with AI at scale, kind of break it down in an example voice agent, and then talk about, because every engineer's favorite topic is how to over-engineer things ahead of when it's actually needed. I'm going to talk about some bottlenecks that you're going to run into as you massively scale your usage of your AI platform, and then how to fix them. And the thing about scale in the AI age is that actually you're not necessarily going to be over-engineering if you're building for massive scale very soon. Companies are scaling from 0 to 100 million ARR in way less time and with way fewer people than ever before. And because of that, you're having to kind of speed run all of the engineering challenges that a company's scaling up to millions of users. And you're also having to speed run that while developing all of this novel stuff around AI. So, what do you care about? Like, what are you trying to optimize for in this process of building these applications to massive scale very quickly? Well, if you want people to actually use your stuff, it's got to be good. Like, the task-specific quality of your models has to be very, very high. It also generally has to be fast. Most of the fastest-growing applications have a real-time component to them. It's got to be like, okay, it doesn't have to be that economically efficient, but it has to be at least economically efficient enough that you don't burn through your whole round before you're able to, go back and get some more. And the most important thing is you need a really strong sense of differentiation. If you're building an application using the same models as everyone else, using the same infrastructure as everyone else, then it's very difficult to get a competitive edge in the market versus trying to figure out how to do some of this stuff for yourself. So all of these things are hard, and all of these things are much harder at scale. And why? Like, what are the challenges? It's hard to get good P99 latencies. It's hard to get good enough throughput to handle high volume, especially when you're trying to keep high availability, even though GPUs go down all the time. If you have a launch day, you could easily say 10x, 100x traffic bursts, and then you have to do all this while managing a model lifecycle that is generally on the order of weeks or maybe months if you're lucky, keeping very granular observability because all sorts of weird stuff is going to go wrong, and you have to beat every single other team to market who's trying to do the same thing while learning new technologies that just got released a few days ago. This is why we're all here, and this is why we're all having such a great time here being AI engineers. So let's just break down a simple example of like why this is hard. What are some of the challenges? So let's say you're building a voice agent for a pizza shop. This is some 101 voice agent stuff. It's got to be able to answer the phone. It's got to be able to take an order and do some basic customer support. Maybe do a couple upsells. We love upsells. It's like, hey, do you want a Coke with that? Do you want some breadsticks? What do you actually have to do? Like, what is the actual amount of stuff you're going to have to deploy to build this? Well, you're actually going to need a lot. First off, you're going to need not just one model, probably 3 or 4 different models. If you don't feel like paying $9 an hour of user time for a real-time voice API, you're probably going to need to build a cascading call between a speech transcription model, an LLM, a speech synthesis model. Maybe you're going to throw in some embeddings there if you need to retrieve, pizza-specific information. You're probably going to need to be able to make tool calls to create orders, maybe recommend similar products. You're going to have a bunch of other models mixed in there, like voice activity detection. And all of this stuff has to run in real time. So what metrics are you looking at? How do you know if you've succeeded at deploying all of these things and wiring them up together properly? Well, the performance is basically going to be an amalgamation of the per model response time plus any network overhead, and that's going to determine how responsive your agent is. This is especially important because one user action in many of these agentic systems can now create many inference requests, like 50 or more inference requests off as a single user action. So when you're thinking about responsiveness, you have to have really good end-to-end response time, but also good individual per model response time so that you can show or otherwise signal to users individual and intermediate steps along the way. So let's say you build this pipeline. Let's say you put all these models together, you get it working, you get it running with, say, sub 500 millisecond latency end-to-end, maybe under a second if you're doing a lot of tool calling and stuff in there, and you ship it, and it works, and that's great. This is amazing. This is the goal, right? Like you ship something and it works. The problem is that a lot of stuff is going to go wrong as you try to scale this, because the truth is, now, by the way, I don't mean to call out VLM in particular on the slide, just in case anyone here is a big VLM fan. I personally use it all the time, just used it yesterday to deploy a model. But the basic premise and the reason that a lot of these systems that get built for the POC have trouble scaling is because you just take a GPU, you take a model off Hugging Face, put it on VLM or similar, put it on the GPU, call it production. And that actually is going to run into a ton of bottlenecks. The 5 places where this most often goes wrong is ignoring the model level optimizations and the modality specific runtimes. But that's kind of what everyone likes to talk about. When you think about model performance, you think like, okay, I want to quantize it, I want to do speculative decoding, I want to do all this stuff that I'm about to talk about. That actually, in many cases with the companies we're working with, is not always the single biggest issue in these kinds of pipelines. Generally, the big problems are actually more around network overhead, client code bottlenecks, and multi-cloud capacity management. Because you can make a model fast, you can get a great runtime, but when you have all of these different models working together, all of this orchestration stuff generally becomes a bigger problem. So I'm going to break these down individually. First off, table stakes, like you gotta make the model fast. And so what does fast look like for a model? It starts actually not in getting really good at CUDA programming or getting more than a B+ in linear algebra, because if that was the case, I would not be able to do it. What it comes down to at the beginning is actually just really good model selection. Not all use cases need the latest, greatest Claude 4 opus in order to create a good output. So having really strong evals, having good observability from Arise, for example, is going to help a lot in just like picking a smaller model. Because if you can get really confident that you can either take something like Llama 8B off the shelf or maybe fine tune it for task specific quality, then your entire life in everything we're going to talk about from here on out gets a ton easier. So that's like the absolute lowest hanging fruit that often gets ignored when we're talking about model performance. Is just like make sure that you have a model that is going to be as easy as possible to improve the performance of. Once you get there, generally you're going to want to do other things to the model itself, the model weights themselves, before you start thinking about the runtime. One of those generally is going to be quantization. A year and a half ago, I probably would have been standing up here telling you that quantization is not ready for prime time. Quantization is for local Llama only. But with FP8 on Hopper GPUs in particular, including FP8 KV cache quantization, we've seen a ton of success in production, including for some like pretty sensitive use cases where even a 1 or 2 basis point deduction in accuracy would be material. We're seeing quantized models in FP8 performing very well, and actually have just started to push some FP4 stuff in production. So these floating point quantizations are doing pretty well. The other sort of model level optimization that you're going to want to do most of the time is some kind of speculation engine on top of this. This is especially going to be important for latency sensitive stuff like code generation. We're working a lot right now with self-speculation, stuff like Eagle and Medusa, where you're actually either grafting additional decoder heads or fusing layers or otherwise modifying the underlying model rather than doing the draft target model dance. So let's say you get your model weights all sorted, everything's ready to go. The next thing is that you're going to need a runtime. So you can use VLM, you can use SGLang. We use a lot of TensorRT LLM in addition to those other two. And what's really cool about building stuff like voice agents is you can actually optimize all of these modalities with the same runtime, which is not obvious. But once you start to see it, it makes a lot of sense. So let's take a TTS model, for example, like Orpheus TTS. It's one of the leading open source it's one of the open source TTS models. And it is Llama 3B. Llama 3.2 3B. What they did is they took it, they expanded the vocabulary size so that they could put a bunch of audio tokens in it, and they fine-tuned it so that you put in text, and it outputs these audio tokens, which you then decode. But again, it's Llama 3B with some customization at the architecture level. Because of that, you can just plug it into TensorRT LLM. Same thing with Whisper, same thing with embedding models. Each modality still has its own quirks. For example, if you're doing TTS optimization, you're going to have to spend a lot of time thinking about audio decoding and how to send audio around properly. But as an example, if you're using an H100 GPU, you've got the quantization that I was talking about earlier. With Orpheus TTS, by using TensorRT LLM, an LLM-based runtime, again, to run a speech model, you can actually cut 50% or more off of your first sentence, so first chunk latency. So that's great. Like, once you have each of these models working individually very quickly, that's the great first step. But the next step is you actually have to make them work together quickly. One big common failure case I see a lot of times with people building these multi-model systems is, especially in the early days when you may be working on multiple providers, all of your latency, or like all of your material latency, is coming from network calls, not actual model inference time. Because if you have your TTS provider that's over in US East, and your LLM you're getting up in Seattle, and your Whisper transcription you're getting, I don't know, in Texas or something, and that user request has to travel all over the country before getting back to the user, it's going to be that network time that is going to be the big bottleneck in your application latency, not actually any of the cool stuff around model performance. So you have to make sure that the geographic latencies are minimized, the geographic proximities are minimized to improve that latency, because every single one of those intermodal calls adds a bunch of overhead. Once you have everything kind of lined up in the same data center, you can do more stuff. You can start doing like cache and LoRa routing to improve performance. For example, if you have multiple voices on your model, each voice is its own LoRa. You can make sure that same requests to the same voice are hitting the same GPU every time instead of having to swap those LoRas in and out. But yeah, that's a very, very critical portion, is minimizing network overhead. It's not always the most glamorous part of AI engineering, but it is one of the biggest sources of gains for large-scale performance optimization. And then the last piece, and something I see teams get tripped up on all the time, is you've done all the work on the model, you've done all the work on the runtime, you've done all the work on the infrastructure, and then you start to call the model from your computer, and you're like, wait, I swear I did a good job. I just benchmarked this entire system, and the whole thing was 200 milliseconds end to end. Why am I seeing 350 from my machine? And there's often client code bottlenecks. A big one is, session reuse. That's like the easiest foot gun in the entire world to skip. But I make that mistake all the time, where I just hit a request.post instead of making a session pool and reusing it. That can take a few dozen milliseconds. That matters in these applications at scale. And then when you try and start to do like really high volume stuff, usually, of course, as AI engineers, we use Python. I love Python. I don't really know any programming languages that aren't Python. But there are some limits usually on parallelism. For example, if you're using a client to do a very high volume embedding processing, where you're, say, embedding the entire internet or embedding 1 trillion tokens to pre-train an LLM, you're actually going to generally be bottlenecked by your client code, even if you're running on a very, very beefy machine. So we actually created one of our engineers, this guy named Michael, he's awesome, he's done a bunch of the embedding work for us, went off and created this inference client, a high-performance inference client for embeddings, and some other stuff as well, that's written in Rust, so it gets around the Python global interpreter lock. And if you're doing like 2 million embedding requests, hitting the same model on the same endpoint compared to the OpenAI SDK, you're going to get like 12 times higher throughput just by fixing your client code. Again, nothing to do with model performance, nothing to do with infrastructure, it's just client code. So the final thing is if you do all of this right, you get your client right, you get your infrastructure right, you get your network right, you get your model right, and everything aligns, you hit #1 on Product Hunt, you go viral on Twitter, There's one last problem kind of waiting in the wings to get you, and that's running out of GPUs, which is a big one. This is a graph from an actual customer of ours who did a huge launch. These are H100 nodes, so you can see at peak, these guys hit like 1,800 H100s. This is more H100s than were physically in their primary cloud provider region. So one thing that is really critical to build or to get access to as you scale this out to the maximum size of these companies that are scaling to tens or hundreds of millions of ARR is being able to get capacity from all of these cloud providers and unify them in a single place. So again, model, modality, network, client code, and cloud capacity management. These are all the things you got to think about when you're scaling to massive, massive user bases with your AI app. That is my time. Thank you so much. Hit me up on one of these things. Check out Baseten. This is my job.
All right, it just 0-0. Amazing. Okay, thank you. I learned a lot. I have to go and I have to benchmark my app after this now. So that was great. Those are our three speakers. So let's have the speakers come on up and sit up here. Grab those three stools over there. And we were going to have 25 minutes of panel and Q&A. And I don't actually know that I've ever moderated a panel, so,
You're telling me I have to sit up here with good posture for 25
I know,
minutes?
the stools. Yeah, you have to, look cool on a stool.
It's very difficult.
Whew. Yeah, maybe we should have just gotten, some beanbags. All right. Okay, let's just start with an easy question here. So what is your favorite model and, why? What do you use it for?
Anybody want to start? That is a tough one. I've actually been using Gemini 2.5 Flash a lot, and it's pretty great. So I highly recommend it if you haven't played around with it much.
Yeah, I think that's a really hard question. I feel like I have favorites for different things. I feel like I'm using a lot of the latest Claude models when I'm in Cursor. If I have something I need to think through a little bit, I definitely will go to O3. But I feel like O3 gets wild for daily tasks if you needed to do something simple. So that's, I guess, my top three.
There are 1.8 million, last time I checked a few weeks ago, open source models on Hugging Face. So it's very difficult to choose my favorite one because, all open source models are great in their own way. But I will say that the model Orpheus that I mentioned in my talk is one that I've been seeing a lot of really cool use cases for recently. Having a open source text-to-speech model that is frontier level has really unlocked a lot of high volume use cases and cut the cost of adding voice to applications by 90%. So that's pretty cool.
Nice. All right. So here's another question. So some people say, 2025 is the year of agents. Now, Andre Karpathy just had a great talk. I don't know if you saw it. It's on YouTube. It's been watched 2 million times now. Everyone should watch it. He just did this talk last week about how software is changing in the era of AI. And in his talk, he said 2025 is, he said we're in the decade of agents, right? He thinks it's going to take us 10 years to fully understand how to build agents. So the question is, what are the agents you feel that we can safely build in 2025? What are the agents you've seen people build or that you want to see people build, to inspire people here?
Yeah, I can start with that one. I definitely recommend if you haven't watched it, definitely go watch it. It's a great video. And I agree that this is the decade. I think people hear Year of Agents, they think AGI in 12 months, we're going to be there, and we're so far away from that. I think the agents that I see successful, a lot of our customers do, are the things that are really thought out, things that are tried and true. If you think about even the travel planning use case I gave in my slides, that's something that's pretty thought of. We know the path to do it. I think those things really, really strong use case. Anything that's a little bit more complicated, it requires a little bit more of that, that reasonings that human have that the AI is just not capable of. Those I think that we're a little bit far away from getting successful at.
One thing I'm seeing a lot of, which I think is a really good way to think about the market right now, is something I would call second order problem agents. here's an example. So coding agents are great. I've been vibe coding basically 100% of my work recently with Coso. I actually yesterday was going to do a client deployment, and I told the CTO that I vibe coded the config, and he was like, no, let me look at that first. And the reason for that, this is kind of where the second order agents come in. So let's say that a lot of software starts getting written by agents. You need agents to watch the agents. You need agents for debugging. You need agents for observability and monitoring. I think like Datadog just announced an agent, the Bits thing, which is kind of along those lines. So, you know, agents are going to solve problems. They're also going to create new problems. And I think that building agents with a view of fixing the problems that other agents create could be an interesting way to look at the market.
Yeah, I mean, I definitely think that we're really early, and that it feels like things are moving so quickly that sometimes you think, oh, it's too late, like people already started working on it, but I do think it's definitely going to be like the decade of agents, maybe longer. I think the way I thought about it a little bit is that I think things where there's a lot of information, like training information on the internet, is probably the best place to start. So this is why coding agents, I think, are so good, is there's so much information on the internet that it can train on. So I would apply that probably to all kinds of other use cases. So if you have some like very niche thing where there's 20 people in the world who knows how it works, that's going to be a much harder agent to build today. I think as context windows get bigger and its ability to manage larger context windows, those things will open up. But in the short run, probably working on things where there's a lot of context embedded into the models already is going to be where agents are built today. And I think that's what you're seeing. I mean, travel agents is a good example. Tons of information about travel on the internet. So the models are already pretty good at travel. They're probably not good at something that's incredibly niche.
All right, so you did bring up vibe coding. And GitHub Copilot actually just went open source today, which was really exciting for us. And we're definitely in the era of AI coding assistance, right? We've got lots of options there. So I want to know your opinion on vibe coding. Clearly, you're totally good with vibe coding things for production, because that was my question. Would you ever vibe code for production? And I think I know the answer for one of you.
Yeah, well, I'm in an interesting position. I don't think all software engineers are, where 90% of the engineering work that I do is very, very cleanly scoped. It's like, hey, Philip, build an integration for this thing. Take this open source model from Hugging Face and build the same model server you've built 100 times before for it. So because I have so much context on what I'm doing, so many great examples to give my agents, and a really clear feedback mechanism for whether or not it got it right, I am able to rely on a lot of this AI-generated code to move faster. Also, like when I'm a DevRel, so like a lot of the things I build beyond that is just demos, and demo only has to survive long enough to make it through a 15-minute presentation. I think if I was writing a more serious type of code, that I might be a little bit more hesitant today to trust these things. But for what I do, it's great.
Yeah, I mean, I'm a big vibe coder. I think there's a time and a place for it. I agree with demos are great. You have to like whip up a special application, or if I have an idea and I don't want to spend hours trying to make it come to life, it's great to do that. I've also used it to help teach. Like I'm a big Python programmer, but I don't know, I didn't know like React, for example, when I was kind of starting on the product side to fix little bugs. So I feel like it's really helpful for that. Where I've seen it go absolutely wrong is in those production use cases, specifically around bugs. We use AI-assisted tools in our engineering org. It helps you go faster, but what is really interesting is I've seen like some of our other folks who maybe aren't in the eng org try to fix a bug, and what I've noticed it just deletes the code. Just deletes it, like no more bug because the code doesn't exist. So I think you definitely have to be careful about what you use it for. You should absolutely be reading over every line of code that it puts out for you. But I think you're not going to be nearly as productive if you're not doing it. So do it, but pay attention is my suggestion.
Yeah, so I had very similar insights to the both of you, but I would say, yeah, obviously the more scope something is, the better it works. So I think one thing I'm thinking about, like I think maybe vibe coding right now is still also very early, but I think one thing that I've been thinking about and a lot on the team is what are the skills you're going to need to develop as vibe coding or AI engineers get better. And I think a lot of it's going to be around communication. How can you write stuff down? So I think we're going to see kind of the revival of the PRD and the docs, and basically really getting good at how do you actually describe what something's going to do. Because I feel like a lot of what a good engineer is doing when you're working with them, or you are an engineer, is you're getting kind of often very, let's say, loose definition of what you need to build, and then the engineer is bringing a bunch of context and experience to that and asking good questions, making good assumptions. And I basically treat any AI thing I'm working with as being like an intern who can speak really well, but is like probably at like an 8th grade level of like intuition. And so being able to write down that intuition is going to be an incredible skill over the next decade.
I like that we're bringing documentation back. It's going to be cool again. Actually, I was for Copilot, you can write like a custom instruction. I think all these all these IDEs and coding assistants have ways you can write custom instructions. So for my repo, I made like a 2-page long custom instruction describing everything about how to make changes to that repo. And I was like, dang, I should have put this in the actual documentation too. Like, this is useful for humans too. So that's nice, is that, you know, if we write documentation for the bots, we also maybe make it better for humans too.
Yeah, and I think actually if you want a good startup idea, is people hate writing documentation. So if you could find a way for somebody who's an engineer who could just like talk or do some sort of interaction, and then it turns it into like really well structured to issues or documentation, that could be a great startup idea right now.
We actually use a lot of like cursor and stuff like that to help with our docs as a jumping off point, because nobody wants to write docs at all. But if you can point it to your code and you can give it a little bit of helpful instruction, you can't post it for users because it's not going to be good enough, but it does give you a good jumping off point.
I talked to someone before this named Roy, who's working on a sort of AI coach, AI therapist type app. And I'm going to need Roy to get me access to that app, because I actually love writing documentation, so something's probably wrong with me.
Well, I like writing HTML tables from scratch, so there's probably something wrong for me. Okay, so you mentioned fine-tuning models in yours, and fine-tuning seems like such a good idea in theory. I don't know how many developers are actually fine-tuning models, and I'm curious what you think, like in the future, are we going to see more fine-tuning? Is fine-tuning going to get easier and cheaper? Or on the other hand, are the frontier models getting so good that we don't necessarily need fine-tuning?
Oh, I can answer it. So I actually haven't done much fine-tuning, and I'm going to steal a friend's like thoughts on this, and I think they're really good. So I think fine-tuning, there's definitely use cases where it makes sense, but I think for a lot of people, it's probably best to avoid it until you have a very clear use case for when you're going to use it. And he brought up some really good reasons about why you should do that. So one, if you are, frontier models are just getting better so much faster. Once you build a fine-tuned model, you're basically adding latency and to be able to adopt like the best model. Even if you're using open source models, there's like a whole process for setting that up. It takes time, it's expensive. You might even avoid doing it because of the cost. And then another pretty big issue with fine-tuning is the risk of embedding like user data into the model. And I know there's tools out there for kind of scrubbing the data and trying to avoid that, but unless you're really religious about that, I would be very worried about accidentally exposing customer data in a fine-tuned model. So just something to consider.
Yeah, I can just speak from like my experience of what we see kind of at Arise. I agree. I don't think a lot of our customers are reaching for fine tuning. I think that they're using a lot of the off the shelf. They're good enough now. I think there's specific industries that are more susceptible to need to fine tune, especially when we're dealing with kind of customer data or API that can't go into the foundation models where they need to fine tune and just kind of own that end to end. But I definitely see a future where those industries, like they will kind of continue and there will be more and more fine tuning happening there.
I want to provide a legally required disclaimer: no fine tuning before PMF. That said, I actually do see a lot of fine tuning in the wild in production for 2 reasons. Number one is just cost. For example, a partner of ours, Greg, he's the CEO of Oxen AI. He does this Twitter series called Fine Tuning Fridays. It's awesome. You should check it out. A couple weeks ago, he fine-tuned a Quen 0.6b model to perform equivalently to a GPT 4.1 on SQL generation. Now, SQL generation is a great candidate for fine-tuning because it's a very clearly scoped task. But you can run a Qwen 0.6b on an iPhone and not even have it heat up too much. So the amount of performance boost, kind of like I talked about, that you can get from switching to a domain-specific fine-tuned model and just having a tiny model that does really well, it's massive. The second reason is, I think all the time when we talk about fine-tuning, we talk about it in the context of LLMs. But a lot of the fine-tuning I see is in other modalities. Fine-tuning voice models is very, very hot right now for custom voices for your product. Fine-tuning embedding models respond extremely well to fine-tuning, and you can get very, very good domain-specific performance. So, with these models being small, it's pretty easy to do the fine-tuning run and pretty cheap as well from a GPU perspective. The difficulty, of course, is getting the data and doing the evals, as it always is. But yeah, for modalities outside of LLMs where, again, like you can do the replicated GPT with a small model trick, it's really cool. But a lot of cases, what I'm seeing is fine-tuning of other modalities to address like other problems within the application.
Yeah, that's a great point. And you mentioned locally hosted models. So that's another question I have is, where our machines are getting more able to run these models. The browsers are actually adding specifications like APIs to be able to call local models. So even from your JavaScript just in the page, you could call a local model. So in the future, when do you think our applications will be using the local models versus the cloud models?
Hopefully not for a long time, because I don't make money when people run local models. No, I'm kidding. It's a really interesting space. It's something that I have a lot of personal interest in. I think that it's one of those cases where the future is here. It's just not evenly distributed. If you think about the top 1 percentile of a technology that someone might have in their pocket, it's an iPhone 16 with 6 or 8 gigabytes of VRAM. It's a brand new Mac Studio with, I don't know, a terabyte or something in there. But the sort of median user, especially the median user maybe outside of the United States, is going to have a Chromebook with 4 gigabytes of RAM, not VRAM, just like RAM, and a 5-year-old Android device. So when you're thinking about how to distribute an AI application to the largest possible audience, I think that we're still a few years away from having the mass distribution of really high-powered hardware that makes local make sense. There's obviously great ways you can work around this, like you've got stuff like Raspberry Pi that's running small models locally. You have a ton of edge inference for stuff like computer vision. The world of edge and local is very, very rich and very vast, but it's also somewhat limited by the worldwide distribution of the actual hardware that's able to run this stuff.
Yeah, I think I feel like one of the biggest selling points for local is probably going to be privacy is the main reason people want that. But I think that when I think about it, we already just give so much of our data away that I actually don't know if privacy is the main reason people are going to be doing local. And I honestly think that, on the server side, things are just getting so much faster and these models are getting better. At a certain point, latency is the other big reason. I don't know if it's going to be the main reason for doing local requests in the next couple of years. I think that LLM requests will be so fast that most people don't really think about it, in the same way that you don't think about making a database request for a lot of use on the internet. But yeah, I definitely think 10 years, 20 years from now, I think that might change and we might do more and more on the client side. In the same way that there's a local first movement today of, Linear, for example, stores all your data locally, so things are super fast. I imagine that will happen to LLMs at some point too.
Yeah, I agree with both points. I think what I see is, again, use case based. Is there a need for you being, somewhere really remote where you need something deployed on the edge? I do have a few use cases like that. But I think for right now in the immediate future, that's going to be the primary driver of that.
Yeah, it's interesting. It is faster for me to call Azure OpenAI than to call a local model on my machine, right? Because of, like the networks, like the hosted versions can be so fast compared to my little 16 gig RAM thinking really hard about it. But once I was on a plane and I didn't pay for that Wi-Fi because it's like $15 for a 2-hour flight. And so then I was able to have a conversation with Llama trying to understand how time zones worked and why it seemed like it was so late in Dallas, Texas. So I was thankful then. I was like, I have a local support, therapist to help me through this weird flight. Okay, great. So let's actually open up to questions from the audience. I know there were some hands during it. If you still want to ask yours, yeah.
I can go first. I think it's tough. I think from my perspective, like when I build Alex and we try to do the scoping there, I think I want to, at this stage, make it as easy for the user to like get an insight as possible, but we feel that it is important for them to still have say and be like interactive. So you can kind of think of it as like if you've used Cursor, of like it writes all the code for you, but you still kind of have to inject like your opinion versus it going all the way. And then I think until I feel like 100% confident that the LLM could like take an input, take it all the way without any mistakes, I'm gonna want the user to be involved. So what that looks like varies, and I think it depends on what the task is, what I think the user is expecting, if they're wanting the LLM to take it all the way, or if they're looking for kind of more of an interactive. So that's kind of how I approach the problem.
Yeah, I think the way that I think about it is, I go back to the analogy of AI as like a really, what's its intuition level? It's still pretty low, even some of the best models. It might be very technically proficient, but its ability to think through like what's good and what's bad. And so when I think about it, I think of how you would also treat maybe an employee or somebody that's working for you, right? So if you hire someone who's incredibly senior, you maybe let them go run off and do things, and touch points are much less frequent. And then if you're hiring an intern or somebody who's more junior, you might have much more frequent touch points. You might want them to get things reviewed before they get sent out. And I think we're definitely in that era of agents where there is going to be much more human in the loop, much more review. And so I think agents are really good at first passes. So anytime you can get the agent or the AI in your software to pick some defaults, generate a first version of something based on context, I think it's like the best model, but then very frequent review from the end user to make sure that things are correct. And I mean, Cursor's a great analogy, or many of these AI agents, like 0 of them are pushing things to production, right? There is always a human that has to click the button deploy. Maybe there's a few companies that are doing that. I would probably be worried of using them, but I think that obviously as time goes on and then trust develops, context gets better, it actually like learns more about what your needs are. Maybe you have it do more for you.
I like to think about this problem from the other direction of, instead of like how can the user help the LLM, it's how can the LLM help the user. A great example of this, there's this app called Whisper Flow. It's a dictation app. It lets you basically just talk to any application on your phone or computer. If you're not using Whisper Flow, you should be, and I'm not just saying that because they're a customer. Anyway, I did a case study with them where we talked about the way that they think about using LLMs. And if you think about a transcript of someone talking, it's not necessarily going to be super polished the way an email or a blog post might be, with formatting and markdown and tables and headers and all that kind of stuff. And so by attaching a LLM, a really small one, to just kind of process the output of the user as they're talking and just clean it up a little bit, they're able to get a product that feels much more natural to use. So there's definitely a lot of really good sort of state of the art in making sure that the human can take the LLM the last 10% of the way, but there's some cases where actually the LLM can take the human that last 10% of the way instead.
All right, thank you. Well, let's go to this question here. Yep.
Do you have any tips on prompting with vibe coding? So that's question number one. Question number two is with AI, so being used promptly in the companies or enterprises, what kind of structure change you are going to see in the companies? Like different people's roles change, or engineering, tester, designer, marketer? Did you see the future? Thank you.
Yeah, I think
The future.
You kind of hinted at this earlier. Is like everybody needs to be a little bit of a prompt engineer. As they're kind of working with these tools, they need to be able to prompt them properly. That's like the key. All of these tools only work as well as their prompt. So I think that's where I really see is people need to understand how to use the AI, how to interact with it. I think that's going to be one of the most valuable skills. I'll take a quick pass at your first question about the prompt optimization. I actually don't think that like Cursor is that good at optimizing your prompts. I will do a little bit of a shameless plug. At Rise, we actually have tools built in to automatically optimize your prompts. So what we can do is we can take in the data, we can take in your eval information and annotations. We have things like expected output, and then we can do an automatic prompt optimization. Right now we're starting kind of with like meta prompting, but there's things like, DSPy. They don't take into consideration the evals, but I think that is actually a way better to kind of optimize your prompt with some assistance than just kind of going through Cursor.
Yeah, so actually it's funny, I was talking to one of our investors about this, and he's been like tasked with this at the company he joined of like, what's the future of product teams and what that would look like. I mean, I probably can't speak to every domain, but definitely in the software domain. Yeah, I definitely think that like what you're looking for in people is definitely changing. So I think in the past it was much more like the skills, can they do the thing that you're hiring them for? And now I feel like the shift has been much more towards taste, intuition, because I think the agents are going to be getting much better at doing some of the kind of task-specific problems. And the people that are going to excel in this future world are people that are bringing something that is hard to quantify in a very like technical well. And I think over the next few years, we're going to figure out how to identify that in people. But I definitely think one of those skills is going to be communication. So it'll be both, how do you communicate the things you're working on, but also how do you communicate to the AI agents that will be working for you. Management, I think, will be like a skill that people think about. Like even ICs are going to have to learn how to manage, teams of agents that are working for them on different tasks. So yeah, I actually had a friend who he's a manager, and he was talking to engineers on his team, and they were complaining about using some of these AI tools, and his response was basically, oh, this is what I do for you, you just don't realize that. And so I think like that management skill is going to be something that like a lot of people are going to have to learn in that world. But in terms of prompting, I don't have a lot of like great feedback. I do think that as time goes on, we talked about like prompt engineering. I think we're kind of moving into this new phase of like context engineering. How do you make sure that the agent has the information? Because one of the common problems that people run into, including myself, when using these tools or building these tools, is you give it these, people are lazy. So people will put in these really vague like messages and expect the agent to figure it out. And what we often don't think about is that they just have like not enough context from that like one message you give them. And if you've ever had to work with somebody and explain to them, what you're trying to get done, sometimes it takes like a 30-minute meeting for someone to like really understand what you're trying to build, what you need from them, what they're building, and then we just drop into Cursor and write, fix this thing and expect it to work. So I think that's going to be, it's not just really about prompt engineering, but like how do you make sure you're gathering all the context, helping the user write better prompts or give better messages, instructions. I think that'll be kind of like the future of this is, I don't think everybody needs to be learning a prompt engineer. I think that the tools should be good at getting the context they need from you.
I mean, as usual, these two nail it. Don't got a lot to add. I will just say that every model's a little different, just like talking to every person is a little different. Don't be surprised if even a model with vision going from one version of Gemini to the next breaks prompts a little bit, and just be willing to rewrite them with every new model you're using.
All right, are we at time? Or, oh, you have a.
So I was at the NVIDIA conference earlier this year. GTC. And they were basically kind of talking about some of the limitations for AI being a power constraint. And that's where you see kind of some of the focus in government kind of loosening some of the energy consumption on how that's going to be. Now, that given and that said, from such a big, player in the AI space, you could say, how does that affect the smaller companies? And at scale, if you were to scale it. Most of the people we work with are more like GPU constrained than power constrained, which I guess is just like a different order of magnitude. You just get creative, right? Restrictions breed creativity. You use smaller models, you fine tune the models, you optimize for throughput instead of latency. There's a lot of headroom right now to get just like more performance out of the same amount of physical resources. And if we get constrained on a resource, then we just like continue innovating on the performance side.
So I can also answer this too. I think so. There's this concept in economics called like the Malthusian dilemma. So there's been this constant problem in any system where you're growing geometrically, is that at some point you're going to run out of resources. You're going to, and Malthus was a famous economist. He predicted that we would have like massive famine or something in the 1700s. But what he didn't foresee was the invention of, I believe, what's it called? We put it all over our plants so they grow. Fertilizer, yes. So basically, they were using fertilizer, natural fertilizer, and then they discovered how to synthetically create fertilizer, and then that basically like massively unlocked the ability to produce food. And I think that we're like already starting to see some of those innovations. Like there's things that people are building like ASICs and chips that are just designed for these. And I imagine that there'll be at least 1 to 2 major innovations in this space that make electricity less of the problem. That's my take, but yeah.
Yeah, I don't feel like I have too much to add there.
So how do you think our devices will change? Was that the question? So our laptops, that sort of thing? And phones?
I think it's kind of similar to how we talked about before. I think it'll be a little while until we start seeing devices, but I think eventually everything will just shift to be able to accommodate it. That would be my take.
VRAM. You just increase the VRAM. I think like Apple is kind of the clear leader here with the M series architecture. If you put more VRAM on the system, you can run bigger models, and I think that's going to be the bottleneck in consumer hardware for the foreseeable future.
So I'm taking a different approach on that question, more about kind of the design of the products, not so much like the technical capacities. So I thought a lot about this, and I think that voice in is going to be a much more popular modality. And I know a lot of people think that's weird. They're like, oh, I don't want to just like talk to my computer. But I don't know if you've been to like any modern office or a coffee shop and you'll see people talking to the computer all the time. They're just talking to people. I think it'll just become more normalized that you're like talking to this agent on your computer. I think voice is a great in, but I think visual is much higher bandwidth to get information out. So I think that we'll still have screens, we'll still have ways to give information to eyeballs. And then sometimes there are tasks that are much better to be interacted with visually than audioly. Like, so if I have like a list of things and I'm ordering it, I do not want to have to describe how I want to order it. I just want to use my hand or point with something or use a mouse to order the things. That's an example. So I think that we'll probably have some split between voice in and visual in, but then mostly visually out. Unless you're driving or doing some activity that you shouldn't be looking at something. Generally, I think we prefer visual as a medium, or at least visual plus audio, like a movie. Most people watch movies, visual plus audio.
Yeah, I think voice input is so important. If you are developing an application, please add a voice input. It's even, you can get it for free. It's part of the browser APIs, or you can use like an actual, hosted model for it. But everybody could have voice input, and it's so good for accessibility, and it's just great for everyone. Yeah. We're gonna actually run models. We got a microphone runner now. Wait, we're gonna run the mic over, just because we're recording this part, so we want to hear everyone's questions.
So comparing to the operating systems, if I compare that with, say, foundation models, the operating system companies have created a moat which was not able to, which the other companies, like say, for example, Microsoft has its own suites of products on top of its OS. Nobody was able to compete on that. In a similar vein, this foundation model companies are also coming to the last mile where they can deploy their own products, like ChatGPT is still the #1 AI product, right? So where do you see we have the application companies, like there are a lot of applications on Windows, Mac OS. Where is the space where the foundation model companies cannot come and eat away the small startups that are thriving at this point in time?
It's a tough question. I heard the founder of Rippling talk about this, and I think he would kind of agree with you. And his thesis was that we actually have lived in an anomaly in the last 20 years, which is where the internet basically allowed for distribution at scales. Like small people could start distributing stuff in a way that they couldn't before. I mean, and music is a great example, right? If you wanted to be a famous musician, you had to go to a record label because they had to physically make records and then get deals with radios. Like there's a lot of, it's actually really hard to distribution. And so what ends up happening is you have lots of big companies that dominate the space because there's just like high overhead to get into it. And that the internet is actually a disruption in that, where now people can just post on YouTube or SoundCloud and become a famous artist without having to even go through record labels. And they still exist, but they are much less powerful and they're much more fractured than they were before. And that his thesis was that AI actually has an opposite effect, and that we're going to see the world kind of grow smaller. I don't actually have a good answer. I think that that's possibly true. I think his assessment of what the internet did is correct. Whether AI benefits from larger companies, I do think that something that's going to change is user expectations are going to grow. You're going to expect every application to be able to do a lot more. And I've heard a lot of people describe this as that the marginal cost of code is going to zero. So I think an output of that is that people are going to just expect that they can go into an application and do tasks that were in other applications. And actually, I mean, not to pitch what I was working on, but why I'm so excited about is I think that one of the big constraints on these software companies growing was that the actual navigation is hard when you have really vertical products. And so you see this across Microsoft, Google. They end up just splitting the app into a bunch of different apps, and then you actually navigate between them using Google search or tabs or bookmarks or whatever. But I think AI is actually going to allow them to bring that a lot in-house. So I definitely think that if you're building an app right now, you're going to have to think about how to go deep in an area, but then how do you expand vertically as well so that you stay competitive with larger companies?
Yeah, I don't think I have a really great answer either. I think you did a really great job there. It's possible, right? We've seen some companies in the last year who have, skyrocketed in success. And then, there's obviously others who weren't so successful. So it's we know it's possible, but it definitely is a hard problem.
I work in an industry where competitive differentiation is, kind of difficult. Everyone has NVIDIA GPUs. Everyone has TensorRT, LLM. How do you stand out? And a lot of it generally comes down to just execution speed and customer obsession, which we've seen in every single sort of highly competitive industry in the past, right? I think a great example is I work with a lot of the salespeople at Baseten, and a sort of pipeline in technology, in tech sales, is medical device sellers becoming salespeople. And medical device sales is a great example of a space where there's so much regulation that the product ends up being very similar. And so go-to-market execution ends up being one of the big differentiators, and that's why, med device salespeople tend to be really great hires if they've been, crushing in that industry. So we've generally found that standing out in the space, which I think would extend to, a foundation model company or an application company built on top of foundation models, just comes down to working very closely with the customer to understand their needs, and then executing faster than every single team you're competing with, which is not a fun answer, but I think it's a real one.
It's a really good question. Okay, I think we'll have one more.
Yeah, great conversation. Thank you for all the comments. So going from 0 to 1 on a product as of a few weeks ago was relatively easy. We've seen a lot of examples of that. We're all doing vibe coding and we got the experience. But from what I know, essentially going to a scale from that point, especially with end user facing applications, is really not, we're not there yet with vibe coding. Now, do you see that, first of all, is that the current state of affairs from what you know? That's number one. And the second thing, do you see that changing in the near future?
I definitely agree that is true of what I see. It's great for building a demo. I think there's things at scale that we have seen a lot at Arise too, that just you don't account for when you're vibe coding, or that the LLM's not accounting for. So I do think we're not there yet, but kind of a theme that we've talked about is we feel like we're going to get there. As these models get better, as we're better at managing context, I think that there is a real possibility. I don't know if it's 6 months, 6 years, how far away we are from it, but I definitely think that there's a world. It's probably not maybe one agent, but maybe multiple agents that can kind of come together to help you get something at scale. But definitely, yeah, not there. Great for building a nice demo that works for a week.
One thing that will help unlock those larger scale applications is giving these agents access to just better tools. If you think about the way to sort of go into production with an application, you're generally just going to use whatever the largest and most popular off-the-shelf thing is. But if you look at, for example, a app like, Amazon's own website, for example, that's not going to be running on a sort of consumer-facing or individual developer-facing platform. It's going to be running on, dedicated hardware and dedicated data centers and all that kind of stuff. So giving agents the ability to go get higher quality and more detailed resources by, again, first documenting all of this stuff that tends to be a little bit more esoteric, you're going to remove some of those bottlenecks to scaling just by giving it better things to deploy on and better platforms to work on.
Yeah, I'm not sure I'm interpreting your question correctly, but yeah, I definitely think the difficulty from getting 0 to demo has gone down a lot. I'm not even sure I would call that 0 to 1, right? Because there's usually a few steps between demo and 1. But I think I've seen two major challenges people have seen going from that to the next level. So one, I think, is if you're building kind of more of a traditional UI, is that I think because the barrier to build these apps is so low, now it's actually just really hard to find people to get to your app again. So it's you can create this really cool demo, maybe you solve a problem that they have, they use your app, maybe they sign up or use your app once, but within 2 weeks now they have 50 different demos for different things, solving different problems in their world, that now they have 20 different sign-up lists. So I actually think the biggest challenge people are facing right now is just probably distribution, or how do you get people from seeing it to actually using it? And then secondly, I think it's that, like I was kind of referring to, especially with all these kind of AI assistant apps, is that the effectively space that you have to be good in is just accelerated way far beyond what it used to be. So many apps in the past were just single purpose apps that you could start with, get some users using it, and now the expectations have just grown so much that once they start using app, they're like, well, why can't I do this? Why can't I add context in myself? Why can't I do Y? And so probably execution is like really, that's why execution is so important, is that expectations are just grown even faster than people's ability. So, yeah.
All right, we are now at the end of the panel. We have 1 minute. So are there any upcoming events that you all are going to be at that people should come see you at?
We're going to be hosting a Founders Friday at the Baseten office on the 16th, I think, is the Friday. It's the third Friday of the month, or second Friday, third Friday. It's on our website. It's going to be fun. We're going to be talking about how to get distribution as a developer tools founder. So it's going to be a good time.
I think the next thing for me is next month I'll be participating in eval's workshop solely focused on agents. So yeah, I'm excited for that one.
Yeah, I already said mine. We're hosting a hackathon this weekend, so you can find me there, and then probably something else in the future.
Awesome. All right, well, thank you. I'll do a little wrap-up slides, but let's do another round of applause.
Thanks.
So we have a couple just resources for you to stay connected to the community, come to future events. Definitely come to the events they just mentioned there. This is the global AI community, which has events all over the world, but there is a San Francisco chapter that has a bunch of events. So scan the code in order to sign up for that one. We also have, for some virtual engagement, we're from Microsoft, we have the Azure AI community. So if you are using Azure Microsoft tools, we've got a discussion forum and a Discord that you can join. I actually do an office hours every week on the Discord. So if you have any questions about Python and AI, it's really fun. Actually, I learn a lot with all the questions that people come. So come for the office hours. It's really fun. You can follow us on Meetup. So if you're on meetup.com, you can join the SFI AI Meetup. And then finally, we already have a date for the next AI show and tell. It is August 12th. We've got one speaker confirmed so far, Oriel from Nimble, but we'll have more speakers coming soon. So we hope to see you all here again. And there you go. Thanks for coming. Feel free to keep chatting, ask the speakers more questions, and we'll be here till we get kicked out, I guess. Yay. All right. Thanks, everyone.
Thank you very much. And we have the space until 8:30.
8:30. Okay.
So we can you can stay here until 8:30 and network and keep talking. At 8:30, though, we will have to, 8:25, we'll have to start working towards the entrance. 8:30 is a hard stop. Thank you very much.
Oh, hi. Hey, I didn't know Langfuse was, because you guys are normally in Europe.